lesson 2 of chapter 1 of geometry. Our lesson today is section 1-2, and it's about points, lines, and planes. And so their objective for today is to understand basic terms and postulates of geometry. And so as we think about this, okay, over here we have this picture of a piece of wood and an arrow. So what I'd like you to do is I'd like you to look at that piece on your paper. Is this drawing possible? Think about that. Okay, well here I have my arrow. It's coming through this bottom piece right here. Then all of a sudden it dips back down and comes through here. Is that possible? For it to go through this board twice when it's coming up from the bottom? Well, if this arrow is not straight, then yeah, it's possible. But this is a straight arrow, so this is not possible for this arrow to do this. And so today we're going to talk about facts and postulates that will help us establish why that's not possible. And so what we're going to learn today is we're going to learn about how geometry is a system that's built on facts, terms, and definitions. So in geometry, some words such as point, line, and plane are undefined, which means that we have to give them a definition. So undefined terms, they're the basic ideas that you can use to build definitions of all the figures that we talk about. Although you can't give them a specific definition, you can give them a general description. And so we have these points, these terms. So the first one is a point, and a point indicates a location, but it has no sides. And so we represent it with a dot, and we give it a letter. We give it a capital letter for its name. Now a line, it's represented by a straight path that extends in two opposite directions without ends and has no thickness. A line contains infinitely many points. So you can name that line by the two points that are on that line. So on our line in this picture we have A and B, and so we name that line A, B, and we write this arrow going in both directions above it to express that it's a line in both directions. Or we can give it a lowercase cursive letter such as L. And so there are two ways to name a line. Now a plane is a flat surface that extends without end and has no thickness. So think about it as a tabletop that goes infinitely in every direction. Okay, it has infinite many lines. And so you can name a plane by giving it a capital letter, or you can name a plane by 3 points that lie on the plane. And so these 3 points cannot lie on the same line. They have to be on at least 2 different lines. And so those are our descriptions for points, lines, and planes. So we're going to build on these descriptions to come up with some postulates. And so our first thing that we know is that collinear points are points that lie on the same line. So think about it, you have your co-driver, they're in the car with you, but collinear, they're 2 points that lie on the same line. And coplanar points are points and lines that lie in the same plane. So if we're looking at this drawing down here, we have a plane, and we have some points, and we have some lines. And so we look at our line QT, and so this QT, alright, this is that line right there. What are 2 other names we can give this? Well, Q and T lie on that line, but so does N, so we can call it N and Q. And don't forget to, on the top, do your double arrow. We could also call it NT. And so make sure those are capital letters. We put that double arrow on it. So those are 2 ways to name that line. And so if we have the plane P, remember, here's our plane P. We can name a plane with a capital letter or by 3 non-collinear points. So if I called it VRQ, well, those don't all lie in a line, but they all lie on that plane. Or I can call it SRV. That would work as well. So all 3 of those, or both of those, along with P, would be names for that plane. And so here's that drawing again. We want to know collinear points. Remember, collinear, they line in a line. And so we want to know the names of 3 points that are collinear. And so if we look at that well, we have this line going through, and we have an R on it, a Q on it, and an S on it. So we could say R, Q, and S. Oops, not R again, but S. And then we also see that we have another line going up through it, and we see N, Q, and T both lie on that line. And so those are collinear. Now if we're talking about coplanar points, coplanar points are points that lie on the same plane. And so I've got this plane P, and I see that V right here, R, Q, and S are coplanar. So there you have it. So what I'd like you to do now is pause the video, answer these next 4 questions down here at the bottom at the got it. What are 2 other ways to name RS? What are 2 more ways to name plane P? What are the names of 3 collinear points? And what are 2 points that are not coplanar with points R, S, and V? When you finish that, you can play the video. So now you can check your answers with mine. 2 ways to name RS, RQ or SQ with those arrows on top. 2 more ways to name plane P, RQS, VRQ, VQS. 3 other names of 3 collinear points, RQV. And what are 2 points that are not coplanar with points RS and V, T, and N. So now we're ready to move on. So we can use these undefined terms, point, line, and plane, to define other terms. And so we say that a geometric figure is a set of points. And so we can use that to help us with stuff. And we know that space is the set of all points in 3 dimensions. And so through that, we can come up with some more terms, and we can define them. So a segment is a part of a line that consists of 2 endpoints and all the points between them. And so the difference between a line segment and a line is that it doesn't go on in infinite directions. It's just that space between them, and we notate that with just that bar on top. So we know that, and then we also know that a ray is a part of a line that consists of 1 endpoint. So there's an endpoint here, A, and all the points of the line on that one side of the endpoint. And so a ray, there's an endpoint, and then there's that arrow, and so we notate that just like that. And we also have opposite rays. And so opposite rays are 2 rays that share the same endpoint, and they form a line. And so we have these rays, this ray CA and this ray CB, and together they make a line. So opposite rays make a line, which we already know what a line is from earlier. And so now we can do some problems with that. So what are the names of segments in the figure at the right? So take a look at this figure. Remember, segments, it's just a section of the line. And so we've got this DE we can name DE. Here's an EF. See if you can find the 3rd line segment in there. And the 3rd line segment would be DF. Right? And so what are the names of the rays in the figure? There's quite a few different rays. We can say that it's EF is one of them. The ray on the top, it goes out towards the F. We could say ED is a ray. We could also say that DF is a ray, and it goes out towards F, and FD is a ray, it goes out towards D. And so which of the rays in part B are opposite rays? Well, the opposite rays, I'm going to circle those ones in green, will be EF and ED. And so let's think through this. I want you to decide EF and FE, they form a line. Are they opposite rays? Explain. So pause the video here and come up with that. And I would say that no, they do not. And the reason why is they do not share a common endpoint. If you go back to our definition for a ray, for opposite rays, they are 2 rays that share the same endpoint and form a line. So no. So a postulate or axiom, this is the next thing we're going to talk about. These are accepted statements of fact. I call these duh moments. A lot of them are pretty like things that you would expect. And they are the building blocks of logical thinking in geometry. So let's come up with some postulates and axioms. So you've already used some postulates and axioms in your algebra class. When you graphed a line like y equals 2x plus 8, that was using a postulate. And so all 4 postulates of today's lessons are part of the point line plane postulate. So here we have the first part of it. Fit through any 2 points, there is exactly 1 line. Line T passes through these points, and it is the only line that passes through these points. And you learned that when you graphed, and when you did graphing in algebra, you only had to graph 2 points. A lot of times you'd graph more, but you only had to graph 2 to make a line. So the intersection of geometric figures is a set of points the figures have in common. And so in algebra, the most basic way to find that intersection of these two lines is to graph them. And so here you see them graphed. And so that intersection is this point right here. And what do we call that? Well, that's a point. And what undefined geometry term best describes the intersection? Well, point. And so through that we come up with the point line postulate part 2. It says if two distinct lines intersect, then they intersect in exactly one point. And so AE and DB intersect in point C. Which, yeah, duh, we get that. And so if we increase that by one dimension, and we're talking about planes instead of lines, well, we know that lines intersect in a point. So what does it look like these two planes intersect in? Well, they intersect right here. And that, to me, looks like a line. And so we can actually come up with a postulate for that. If two distinct planes intersect, then they intersect in exactly one line. And so for planes, there's definitely 2 points that a plane has to have in common, and we know that because of our postulate 1 when we said that a line is made up of exactly 2 points. And so the point line plane postulate tells us that it'll be a line, that intersection of 2 planes. And so if we're going to find the intersection of 2 planes, each surface of this box to the right is part of a plane. So we've got 6 different planes because there's 6 different sides. So if we have the plane ADC, so that is AD and C, that's this plane right here, and we have the plane BFG. What is their intersection? Well, their intersection would be this line right here that they go through. It would be BC. And don't forget that they're planes, so they go in infinite directions, which means your line goes in infinite directions, and so it's not just a line segment. So here we have another drawing, and so what I'd like you to do is pause the video and answer these next 2 questions. So here you have my answers to this question. The 2 planes that intersect in line BF are CGF and EAB. Notice when I name those, I named them in order. I didn't just go AEB. I went E. I started at E, A, B, C, G, F. And then why do you only need to find 2 common points to name the intersection of 2 distinct planes? Well, because the intersection is a line, and a line is made up of only 2 points. That's why. So when we name a plane, we need to use at least 3 corner points in consecutive order, which I just kind of went through. When we're naming these planes, if we're looking at the top of the box, we can use 4 points, sorry. But we do them in order. So we go A, B, C, D, or we could do the other way. We could do A, D, C, B, and then we have our planes. And so notice we're not going A, B, or A, C, B, D. We're going in order. All right, and so if we think about that, if you've ever done any photography using a tripod, there's three legs on a tripod, which makes contact with the plane that it's resting on in 3 places, and it's level. And so this illustrates postulates 1 through 4 that we've talked about. So postulate 4 we haven't quite gotten to yet, so here it is. It says through any non-collinear points there's exactly 1 plane. So here we have plane P, and points Q, R, and S can be used, is the only plane that contains these 3 points. Alright, and so let's actually use this postulate what plane contains NPQ. So when I do this, I take those points and I try and draw between them. So NPQ, well, that's this plane right here. What plane contains J, M, and Q? Well, we've got J, M, Q. See how it goes diagonal through, which means it'd go over to P and up. So this plane that cuts diagonal through that box would contain them. So what I'd like you to do now, pause the video, answer question 4A and B. So here are my answers to this. You can see my plane shaded in, and you can see that either JM or ML would be coplanar with those 2 lines. And so your homework for today is to Here's your actual homework assignment for today. It's also posted online. Make sure you may want graph paper for some of it, but it's not necessary. This is the end of lesson 2 of chapter 1 of geometry.